atomic swaps between Monero and Bitcoin. Quick intro what the talk will be about, because it's not only about the swap, it's also bringing the swap to users and making it usable. So first we will give a short introduction who we are, then we will talk about our minimal viable product that we are currently developing. First a quick why do we actually need Monero Bitcoin swaps, then we talk about the current MVP status, and then we actually do a technical deep dive into the protocol to showcase why we decide the MVP in the way it is set up. And then we give a short outlook. This presentation was designed for crypto natives and techies as developers. Like the second part is especially technical. The first part is for people that already know something about crypto. So if you're a complete newbie, you might get a bit lost in the second part. Fair warning. Who we are. So we are Coblox. We're the Commit and Blockchain Research Lab based in Australia. Our software is completely open source. We are the Commit network on GitHub. And from 2018 till 2020, we have been focused mostly on HTLC, hash time lock contracts based atomic swap protocols, mostly between Ethereum and Bitcoin, focusing on ERC20 tokens, mostly stablecoins. Our flagship project was Committeras, which was a daemon that was supposed to become a big thing in the decentralized space. We were focusing on attracting developers to build on top of our protocols rather than developing products. But in 2020, last year, we came to the conclusion that the space is just not there yet. Cross-chain atomic swaps are something still fairly new, and there are only very few solutions out there that actually target users. We also talked with various other projects in the space and saw that people came to similar conclusions. So we decided to do smaller, more contained projects with a more specific focus, specifically privacy and anonymity. So we did a prototype for green Bitcoin atomic swaps, and then started going into Monero and Bitcoin and Liquid, also being like privacy preserving. Additionally, we did anonymous atomic locks. If you're interested in that, just ping us. If you want to join our community, we are on Matrix. There is a QR code in the top right corner. If you scan it, it will lead you to the Elements app and the Commit channel on Matrix. So why Monero to Bitcoin swaps? Well, sad news has struck us quite recent that XMR-TO is the next project in a long line of projects being shut down because regulators are making it more and harder and harder to run services that don't do KYC on trading, especially when it comes to privacy preserving coins like Monero, and Monero being the strongest and most advanced one out there. So atomic swaps, where you basically trade peer-to-peer, you don't have a central exchange at all, but you set up transactions in a certain way between two users directly and then just exchange money, are the thing to come. But we are still far from having this completely decentralized world that we would like to see. So one thing that the Commit team really thrives for is having open decentralized finance, and we hope through atomic swaps to achieve at least part of that. And besides that, it's cool tech, and we are mostly techies. Swap. So let's have a look at what an atomic swap is. This is very high level, and the Monero Bitcoin swap is a bit more complex, but let's quickly get an overview what the point of such a swap is. So first there's a communication phase. You have two users. Let's have Alice and Bob has some Bitcoin and Alice has some Monero. And Alice wants the Bitcoin and Bob wants the Monero. So they have some kind of communication phase. You don't have to imagine this as two users chatting, but more like a program on both sides being set up. and they communicate to agree on necessary transactions, which are basically defined by what we call protocol. And then Bob locks up the Bitcoin on the Bitcoin ledger, and Alice locks up the Monero on the Monero ledger. Then Alice redeems the Bitcoin, basically claiming them, revealing a secret, and that secret on the blockchain, and that secret can then be extracted from the blockchain since it is public by Bob, and he can redeem the Monero. Additionally, there's like a refund scenario where Bob would be able to take back the Bitcoin if Alice doesn't move, and Alice would be able to take back the Monero if Bob doesn't move. So, as in requirements for a user, you would have, logically, both of them have to have a Bitcoin and a Monero wallet. Both of them have to have a connection to the respective blockchain, as they have to monitor what is going on in the respective blockchain. And both of them, since this is not really feasible to be done by a user, would use a program to do that we call swap daemon, that would basically do the monitoring for them and is connected to the wallet. So it communicates with the other party for the setup, then sends transactions for lock and redeem, and monitors what the other party has done on the chain. So let's talk about the minimal viable product that we are currently trying to set up. So first, there will be a web page. Suppose there will be a web page. We focus on a single maker MVP where you can only buy XMR. So you basically have a web page that displays a price. That price actually coming initially because there is no decentralized trading network behind it yet from a central exchange, which can be queried, right? You can just get a price from somewhere and display it. And then we display a command, because the first version, the execution daemon, would not have a graphical user interface yet. But we already have mocks and designs how that could be done. If you're interested in more features of what this web page would look like and what it would offer for the user, you can take a look on GitHub at our issues where we track the progress of this. Additionally, there is the command line interface. That's what I referred to as swap daemon or execution daemon earlier, where we decided that full nodes are not required, although they could be provided, because it of course is safer for a user to run nodes, blockchain nodes, as in a Bitcoin full node and a Monero full node by themselves. But for users, it is hard to do that, so we decided that they should not be a necessity, that they should not be like obligatory, but one can plug into public nodes. But users for the MVP would still have to run the Monero wallet RPC by themselves and unlock a wallet in there. Integrated, then the tool features an integrated Bitcoin wallet that is set up using the Bitcoin dev kit. For the developers out there, that might be interesting. First, the tool would have to be funded. So you could, for example, say, okay, I have money on a central exchange, I just send it to the swapping tool directly, and then you could swap into Monero as a user with like the information you get from the web page. There's a generated Monero wallet, and the Monero can then be withdrawn from the swap tool. You always hold the keys in that whole setup, of course, and all of the code for the CLI, as well as the web page, as well as what we will talk now, is open. Like the third part is open source. Again, there's like the issue where we track this. Here's an overview how this would look. If you're interested in actually seeing a testnet to StageNet atomic swap, StageNet being Monero's instance of a mainnet network, basically, but with test money. So it's pretty much like Monero is, but with test money, and testnet on Bitcoin being basically also a network for testing that is next to mainnet. So this is pretty much like the real deal, but not with real money yet. We also did it with real money, but that's a different story. Like if you want to know about it, we can talk about it. Then you can follow this QR code because we actually have a video showcasing this. The third part of the MVP is the party you trade with. As a user, like if you imagine trading, you always need a counterpart, right? And if you're a user and you say, hey, I want to have a good rate and I want to trade, you have to find somebody that offers you that, especially when it comes to peer-to-peer. That is not a trivial problem to solve. You have something called discovery, like maker discovery. You have problems around decentralized order books. We have actually looked into this, but we decided to just have a daemon at the web page. The web page basically showing the rate that the automated swap backend would provide. And this backend would just accept, so when a user goes to the web page and he copies the link, then this single market maker running the daemon would be triggered and would say, okay, I accept this trade, and then they would set up the atomic swap and actually swap money. For the automated swap backends, it's the same. It's also completely open source, and anybody can come and use it, set it up, and improve it, so anybody can become a market maker. So why this single market? Like, why did we go for this setup? That is, the current protocol has different incentives on Bitcoin and Monero. By the end of the presentation, we will go into that a little bit more. I already mentioned discovery and liquidity. Decentral maker discovery is not trivial to achieve. Generally, like, decentral problems are not that easy to solve. Bitcoin has been out there for a while, Monero has been out there for a while. But setting up a trading network is another thing. Ensuring liquidity in a decentralized network is not trivial neither. If you have a single market maker, I mean, you will know when there is no money anymore, and you can just easily refund. And protecting the user, that was something that the community actually pointed us to. I mean, of course, we also had it in the back of our head, but especially when it comes to Monero to Bitcoin swap, you have, if you are, as a user, would receive Bitcoin, then you would have to make sure that those are not tainted Bitcoin. There's a huge amount of tainted Bitcoin out there, and you would have to make sure by that yourself as a user, because if you don't have a central exchange protecting you and you do everything by yourself, then you would have to make sure yourself as well. But this is just a start, so we are actually working. I didn't fix the typo. Cool. It's still a protocol. We are working on a protocol version where Monero moves first, and we are working on maker discovery, and we are working on decentralized order books. We actually already have a solution there, but we don't think the world is ready for that yet. Join us on Matrix and help us build the decentral work. This especially is for developers. If you are interested in joining the community, have a look. And now, deep dive. Yes, and the pointer, because now it's becoming important. So, adapter signatures. So, I cannot really ask the audience because they cannot voice their thoughts that much. But I mean, usually I would ask who knows about signatures, and we're not talking about the ones on paper. And then I would be like, okay, so who knows about adapter signatures then? Anyway, adapter signatures are a concept that is similar to hash time lock contracts, as in that you reveal a secret at a certain point in time by publishing a transaction. Like I'm talking about adapter signatures here, not in a mathematical context, and I'm talking about adapter signature here in the context of XMR-BTC swaps. One can use them for different things as well, but let's just keep it like that. It's already technical enough. Adapter signatures have different names. They are also called scriptless scripts. They're also called one-time verifiable signatures. One interesting aspect is that they enhance privacy, because you don't use a scripting language to basically put your logic on the blockchain, as in like how to unlock the transaction, but you use like a pure signature scheme, so you cannot really distinguish it from other transactions on the blockchain. Here is a written explanation of what an adapter signature actually enables. Adapter signatures are a cryptographical construct that enables one party A to sign a transaction in a way that reveals information from another party B to party A upon transaction publication without having to reveal the full signature directly. And in order to do so, both of them have to agree on which transaction is to be signed and the encryption key. So that means they have to exchange information prior to being able to come up with this adapter signature. So on a very high level, the XMR-BTC swap, like if you remember like the slide in the beginning where I was talking about swaps in general, here a bit more, we have like the communication phase 1, where Alice and Bob agree on a set of transactions and corresponding signatures. We have then the locking phase. That's basically the same as like before. Bob locks on Bitcoin, Alice locks on Monero. Then we have a second communication phase. Here you can already notice that it's a bit different because in this protocol, Bob actually sends an adapter signature to Alice to allow her to redeem the Bitcoin. Then we have the redeeming phase where Alice redeems first, revealing Monero's signature part for Bob, so a key. So on Monero they have like the transactions locked by 2 keys, one being in Alice's hands, one being in Bob's hands. And through this adapter signature scheme, Alice actually reveals her part of that Monero signature on Bitcoin, and that allows Bob to redeem the Monero then. No worries, I will talk about this in more detail later. This is just basically to give you an overview of how the whole thing works and put it into words, and then I will show you like pictures and step you through the protocol. Bob redeems claims to Monero then because he now holds both signature parts. Additionally, for this protocol, there is a refund scenario where both of them could take their money back. But additionally, which is also kind of unique to this protocol, there's a punish scenario because Monero does not have scripting abilities and doesn't have time locks. Thus, all of the incentivation logic has to be on the Bitcoin side. On notation. The next slide after this slide will basically step you through the transaction setup and then like the flow. It's gonna be quite technical. So here's a few things on notation. Yellow transactions, yellow boxes here are Bitcoin transactions. And the name, as in lock here, indicates what this transaction is for. The red boxes are Monero transactions. The red boxes are Monero transactions. This box here, as well as this box here, indicates the spending condition of this transaction. In this case, it is a multi-sig. That means that both keys have to, like both signatures to be proven against those public keys have to be provided to spend from this transaction. A and B, like capital A and capital B here represent the pub keys used for proof when the transaction spending from this transaction is being published, and the private keys small a and small b would be in the hands of Alice and Bob, like A and B always indicating Alice and Bob. This sign here represents a conditional lock. That means that multiple transactions can spend from this transaction. Only those transactions that will be like visualized like this can spend. So you cannot just come up with a different transaction. This is basically what the whole protocol is about. So you come up with a set of transactions and you say this is how you're able to spend, and there's no other way to do it. And you ensure this by distributing signatures in a certain way. Here you have like two signatures that are required to spend from this transaction, in this case being like sig A redeem and sig B redeem, where sig B redeem is actually an adapter signature that would reveal a secret. One can see that here. This transaction as a transaction spending from the lock transaction, this transaction would actually give Alice the money, a final transaction where only Alice is able to spend from afterwards. Through the adapter signature here, we would reveal a part of a key that can then be used for Monero. And this transaction is a normal pay-to-public witness key hash if you use addresses like that. So this indicates that something is revealed through the adapter signature. Okay, now we have the Bitcoin ledger and the Monero ledger. you can already see that there are different scenarios indicated on the bottom, as in like lock, redeem, refund, and punish, and that there are 2 time locks, T1 and T2, and only after T1 one goes into the refund scenario, and only after T2 one goes into the punish scenario. On Monero, the whole setup, so this slide is about the transaction setup, as in like what do the parties agree upon before they actually start executing the swap. The Monero setup is relatively simple. Like I said, Monero does not have scripting language abilities like Bitcoin or like Ethereum, for example. They have smart contracts that are even more elaborate, but let's not talk about that here. On Monero, it's basically a transaction that is where the spending condition is guarded by 2 keys, MA and MB, where SIG MA and SIG MB would be needed to spend from it. And in the beginning, Bob only has MB, and Alice like SIG MB, and Bob and Alice only has SIG MA. On Bitcoin, it's a bit more complicated. We have the lock transaction that is a multi-sig. So again, both signatures are needed to spend from it. From that, like there are only 2 transactions that can spend from that locking transaction. That would be either redeeming or cancellation. The cancellation, like you can see here, that the signature scheme here is that you need signature A redeem and signature B redeem, where signature B redeem is a multi-sig that would reveal MA that, if you pay attention, is then used here. So this is like Alice's key part that Bob can then use because he already knows this to redeem. Or it goes into a cancel scenario if this time lock has passed. How does this time lock work? Very simple. It is a relative time lock. So when you publish this transaction, it is at a certain block height. The parties have agreed. Let's say it's block 5,304,000. The parties have agreed that after 10 blocks, you're able to publish this cancel transaction. This is like another guarding condition in like that they agreed upon before in the transaction. So I said 5,304,000. I don't remember. 5,314,000. Then they are able to publish this. Cancel can be published by both parties because afterwards there are again 2 scenarios. So from the cancel transaction once that was published on Bitcoin, Bob could go for refund. Here an adapter signature being used again that would reveal his key part on Monero, here being the MB, that Alice, knowing MA, could then use to refund, claiming the XMR. Or a punish scenario where there is this second time lock in place, because in a case where there is no redeem and Bob doesn't refund, Alice would not be able to take back her money, right? So she's able to punish Bob, take the Bitcoin, and leaving him with nothing. So after the communication phase, when the people have agreed upon these transactions, you basically have a certain setup where Alice knows a certain set of signatures and Bob knows a certain set of signatures. So Alice on Bitcoin knows SIG A redeem, so she has like part of the redeem signature. Bob still holds the other part here. That's also interesting. I didn't show that yet. That will become evident when we talk through the actual execution of the swap. That will be the next slide. For cancel, both hold the relevant signatures to be punished, but remember, cancel is also guarded by the time lock, so they cannot initially just publish that. For punish, Alice holds both signatures, and for refund, Bob holds both signatures, where one of them is the adapter signature that would reveal his key part to Alice for refunding the Monero. Monero, very simple here. Alice just holding her part and Bob his. So now we have talked about the setup, as in like what do they agree upon. Now when it actually comes to the execution, what would this execution daemon do for you? So it would first publish the lock transaction for like Bob's side, so both of them are running the daemon, right? So you have like Alice and Bob running this software. Then the software would say, okay, we agreed upon a swap. This is what we call like a negotiation phase where they agree upon price and whatnot. In the single market maker setup, this is actually fairly simple because you basically have to accept what is advocated on, like what is advertised, not advocated, advertised on the homepage. So Bob publishes the lock transaction, like his daemon does that for him, of course. And then Alice's daemon notices that on the blockchain. So it sees, okay, Bitcoin has locked. I lock Monero now. Monero is then locked. Then we remember Bob was still holding the redeem signature that would allow Alice to redeem, like his part of that. There is this adapter signature that would reveal parts on the Bitcoin blockchain. So he passes that over to Alice. That has nothing to do with the ledger. This is actually communication between the two. So the swap tool would basically exchange this information, send it over from Bob once he has noticed that the Monero has been locked by Alice. And then Alice is able to redeem. And in the redeem scenario, she has to use this adapter signature, which would reveal the key for Bob on the blockchain again. So Bob swap daemon notices, okay, Alice has published this transaction. This key is available, extracts that key from the blockchain, and then is able to claim the Monero. Here, quick fun fact detail, since we're already so deep anyway, there's actually no additional transaction needed for claiming the Monero, because you can use generate from keys. So since either party, since only one party in this protocol can hold both keys, either in redeeming, where it is Bob that holds both keys, or in a refund scenario where it would be Alice, they don't have to spend immediately from this transaction, because they are the only ones that can unlock it anyway. Besides, like we talked about redeem, so this is usually how it would be, right? So if you're a user, you would, let's say we buy XMR, so we are in the role of Bob. The transaction fee wise, it would be like, okay, you have to publish this Bitcoin transaction, and that's it. Because this is paid by Alice, and you basically just claim the Monero. So let's talk about refund. We have the swap daemons running again on both sides. Alice started it, Bob started it, and Bob locks the Bitcoin. Alice locks the Monero, but now Bob somehow doesn't send over the redeem signature, his redeem signature part to Alice. So Alice is like, oh, that's not good. I cannot redeem the Bitcoin. So she can eventually cancel. Bob can also do that. So they can both publish this cancel transaction, which looks exactly the same for both of them. And then Bob is actually forced to refund. Because if he doesn't do that and the second time lock expires, Alice will punish him and just take the Bitcoin. So he wants to take his Bitcoin back now. So he refunds the Bitcoin, revealing with the adapter signature here the key part, like his key part of the Monero transaction, and Alice is actually then able to extract this and basically claim the Monero. Similar as for redeem, she doesn't have to publish a transaction for that because now she's the only one holding both of these keys. Punish, so let's say Bob actually doesn't go through with refunding, then we have this punish scenario that basically protects Alice from being scammed by Bob here, as in locking her money. It's like a drainage attack in a way. So in this scenario, we would publish cancel, and if Bob doesn't refund, as explained before, Alice can punish him taking the Bitcoin, and this Monero would actually stay locked up forever. So Bob has a very high incentive to publish this. Outlook. This protocol has certain implications. As you could see, there's a lot of things going on the Bitcoin side, and the different cryptographic roles as in Alice and Bob have different incentives on moving. There's a certain tendency towards like the buy XMR side, as in like Bob buying XMR for his Bitcoin, always has to move first, and Alice should be in the role of the market maker, because Alice is not in the role of the market maker. She can never ensure that like the user trading with her would move at all, and there could be a drainage attack, as in there are like a lot of users constantly saying, hey, I want to trade, you lock up the money, but then there's no move and you lose transaction fees over time. So Alice wants to be in the role of the market maker, but that means since this protocol cannot just be turned around because it heavily depends on the scripting abilities on Bitcoin, it is you don't really want to do both sides yet. That's what we decided, but we're actually working on a protocol version where you can turn it around and where you would allow the Monero side to move first, based on the development of adapter signatures based on Monero's ring signature scheme, which is still work in progress. So that's also one reason why we said at the moment building this huge thing with decentralized maker discovery and whatnot is probably just not there yet. Give it a bit more time and we will get there. We actually submitted a paper to a workshop. Since it is not accepted, we don't name the workshop here. If you want to have a look on how this other protocol looks, you can have a look there. It is scientific, fairly warning. And yeah, we were actually going for a question and answer session. So maybe if there are questions.